Good evening, friends. Welcome back to another session on logistics analysis. In today's session, we will be discussing on supervised learning technique. And in supervised learning technique, we will be discussing on KNN. And another name for KNN, that is K nearest neighbor, is lazy learning algorithm. Right? So KNN algorithm can be used when your output variable is continuous or numeric. Right? When you say y is equal to numeric, right? And you say is categorical. That means it can also be used when your output variable is categorical, right? And it is same in case of naive Bayes. Right? It can be used when your output variable is categorical. Even here. So it expects your variables to be in categorical form. So what you do is you discretize, meaning you convert. Okay. So let us look at a problem at hand. So let's say you have these handwritten digits, right? And you need to classify whether these belong to 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? You have these handwritten numbers. And you need to classify and assign a number to one of these classes. Okay. Now, what do you mean by class? Right? So here, by looking at this problem, tell me how many classes do we have? So by just looking at this, you should be able to tell that we have 10 classes. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is a 10 class problem. Okay, and it can also be called as 10 class classification problem. Okay. Now, if you want to classify which category your handwritten digit belongs to, you need to train your model, right? We spoke about this, training the model, right? And when you look at a new handwritten digit, it should be able to automatically go and sit in one of these classes, right? So it should be, or it will be automatically get assigned to one of these classes. Now, in this scenario, in what kind of situation we can use this application? You have this area transit packages. These are packages. That is, these needs to be delivered. Okay. And there are few instructions on this package along with the details. For example, you might have route, you might have the description of the product that is in the package. You might also have the type of shipment handwritten on these packages, right? That needs to be shipped from one place to another, right? You might also have codes, okay? These transit codes, right? In logistics industry, we have these transit codes pertaining to the route and the means of shipment, by air or by ship or truck, etc. Right? For example, you have a flight number written, something like this. Okay, and this is a handwritten note, and it should be able to recognize these numbers and sort the packages to which in which container or the transport it fits in or it belongs to, for that matter. Okay, it might also have the destination. We already have the flight number, the aircraft number, right? So it should be able to identify and sit in the particular aircraft. It should be sent over in the particular basket, something like that. Okay, you might have few aircrafts, okay, going towards the north, right? You have few aircraft moving towards the south, as well as central, right? All these happen automatically, right? Can you think of any other application? Aircraft 1, say it is heading and covering all the locations in South of America, but aircraft 2 is covering all of the North America. Aircraft 3 here, the central area is covered. Aircraft 4 is looking after the east. Aircraft 5 is looking after the west of America. Right? All of this should be done automatically. Right? And once you have that information, you might also have few billing details within the department, right? The industry, the logistics department might also want to pay for the packages initially, and then they might get it, encashed later, that is reimbursed later for the bills they have already prepaid. The prepaid bills might also already be redeemed. For example, let's say this particular package is costing around $500. Okay, and it is handwritten along with the address, aircraft number, all of that, and it should be able to identify the amount that particular department has to make payment, right? So all of this information is going to the logistics department. The amount that needs to be paid, the aircraft it needs to be shipped to, and the area that particular aircraft is covering, all of that information. Okay. Now let us try and understand this part here. Let me get this. Okay, just give me a moment, friend. All right. So let us try and understand this part. Suppose you have two classes. One of them is blue, that is blue class, and the other one is pink class. Okay. and make sure that there are two existing classes. Now, if let us look if there is a new entry which is coming up. Okay, so whenever there is a new entry, and you will be able to use it and find the distance of that new entry. Okay, with all the points you have, right? With all the points, then you will have to find all the distance. Now, how do you find the distance between 2 points? What are the methods? Right, you have Euclidean distance, Manhattan distance, right? And then you also have Mahalanobis distance. Right, of course, there are others as well. Hamming distance. Right, these are few distance measures. So we can use any of these distance measures and calculate the distance. So we are looking at if k, that is in knn, you want to look at if the value of k is equal to 1, right? Then you find the one closest value, that means 1 point which are the least distance. Least distance here. Okay. So if that observation is closest to this particular pink class, then you will assign a new entry into pink class. Right? Remember, friend, k nearest neighbor is supervised learning technique. Right? Predictive model. And k means is unsupervised learning. That is, k means clustering. Right? We looked at it in our previous session, right? So now let us understand if in knn, the k value is 2. You're saying out of all the distances, this new point, you find the distance to all the points, right? Now, how many points should I choose? 2 points. Or 2 nearest points. That is nearest points which have the distance with new point. So one point is your pink class, another closest point will be your blue class, right? That means one is blue and other is pink. So now if you look at this, there is a conflict, right? Since there is conflict, what do? How do you think KNN works? K nearest neighbor usually works on basis of majority voting, right? So out of these 2 points, there is a conflict. One say that pink and the other is blue. Now your algorithm is confused, like what am I supposed to do? Which class should I assign the new point to? Would it be pink or would it be blue class? For that reason, we always use K value. Okay, we use an odd number. Right? Remember this time. K value is right. By confining your K value to an odd number, you are avoiding the conflict. Either you use 3, 5, 7, something like that. For instance, if I go with 3, okay. So if I'm looking at 3 as my K value, and suppose there are 3 nearest points. You have blue class, pink class. 2 of them say that this is or this should be the pink class, right? Or let me put it this way. These 2 should belong to pink class, and only one says it should belong to pink class. That is, I'm sorry, I am so sorry. That is blue class. I was looking at the color. So it is, one says it should belong to blue class, and 2 says it should belong to pink class. Now, what do? You look at the majority of votes, and what does your majority vote say? Your majority vote say that new point should be assigned to pink class. Right? And this is when your output variable is categorical. Right? You're saying your Y is categorical. Okay. Is the aircraft on time or delayed? Or you can say aircraft delayed or cancelled. Right? So what all aircraft you put? Which class do you put? Let's say you have these, all these aircraft. Okay. So this one, for example, is delayed. Okay. And the majority says it is going to be cancelled. Right? That means you're looking at, though they are moving, that is heading towards the same direction in a course, okay, one is delayed and the other one is cancelled. Right? So for example, you say this particular aircraft is delayed and this is cancelled. And when you look at your majority, you say the aircraft is, when you're trying to put them into a class, you go with the majority and the majority says it is delayed. Right? What if the output variable is numerical? What about numerical output? Let us say you are trying to predict the mileage of the aircraft, how much fuel it is consuming. Right? It has to calculate that, right? It has to predict. Okay. So now let's say you have this carrier and you have a distance. Okay. And you're going with 3 NN, that is 3 nearest neighbor is what you're going with. For a new aircraft, a new carrier, these 3 carriers are very similar. Okay. And the output variable is numerical. What do you do in that case? How do you get, for example, it is one carrier is able to cover, okay, let us look at a toy example. Okay, Let's say a cargo aircraft can cover about 300 miles, okay, of say 500 gallons of aircraft fuel. Okay, remember friends, aircraft use a special type of fuel that does not go with our ordinary gasoline or the fuel that we use in our regular vehicle, right? One is covering up 300 miles per 50 gallons, and the other one, the other aircraft, is 200 miles per 50 gallons. What do you do in this case? So if you simply look at this, you go with the average, right? So let me put it this way as well. And you have another aircraft, which is 400 miles per 50 gallons of aircraft fuel, highly inflammable. So we go ahead with the average. You say 300 miles, 200 miles, 400 miles. Right? And then once you have the average, you say that the new aircraft, it can cover up, basically its mileage would be close to, let me bring this, yes. So we were looking at the mileage of 3 different aircraft. Okay. So when you have 3 different aircraft covering up the 3 different distance for a different, for the same fuel it is consumed, you go with average, and for a new aircraft it would be somewhere around 300 miles per 50 gallon. Okay. We understood that when the output variable is categorical, you go ahead with majority voting. When the output variable is numeric, you consider the mean, right? Okay, controlling complexity of KNN. Okay, here the hyperparameter that you deal with is called as K value. Okay, and you keep changing your K value, and hyperparameter is that option in algorithm which you can change, right? And the change in which, that is, the result will change in the accuracy. Right? That means if you change the hyperparameter, there will be change in accuracy. Okay, you keep changing your hyperparameter, keep calculating the training accuracy and the test accuracy, and it is a repetitive task. You keep doing this. Okay. Right. For example, let's say you start with the K value is 25, 21. Okay. And then you keep experimenting with this. Okay. So the K value is 3, 5, 7, so on, so forth. Once you get to 21 and do 23, your training accuracy is increasing and your validity, that is validation accuracy, is decreasing. Okay, the training accuracy increases. So these are getting diverged, and when these get diverged, what is this phenomena called? Both your training and validation accuracy together are increasing. That is increase in K value. Okay, and assume beyond this point, increasing the K value, the difference between training and validation is getting increased. Beyond this point, the accuracy. And what do you call this phenomena? We call it as overfitting. Okay, and what is another name for overfitting? Variance. Right, so if you use K value which is more than this, for example 21, your model will be overfitting. Okay, and you will be experiencing variance. And if you have a K value which is less than 21, okay, less than k is equal to 21. Then what do you call this? This is underfitting or bias. That means there is still room for improvement. And if you use k is equal to 13, that means you're not building a absolute right model. Okay, maybe you have scope to increase it further until the point where increase in k value will start diverging the training and validation accuracy. Right? You have to keep this in mind, friends. Okay, until then, you keep increasing the k value. Right? Ideally, you know what people do is they use k value square root of n by 2. Right? So now let us do hands-on on our model. Let me launch Spider quickly. I'm importing the libraries. But I'm saying flight is equal to pd dot read underscore excel. And I'm passing the path. Okay, I will replace my forward slashes to backwards. That is backward slash to forward slash. Why am I doing that? Because that is how Python will understand these things. Right now I'm doing a label encoding. I'm saying flight dot columns. Okay. So here is my data frame. Right. I'm saying I'm looking at these values. Unique values. All these arrival time, right? I'm importing label encoder from sklearn import preprocessor. Now let me encode the labels in column. Okay, I'm saying flight is equal to flight dot index location. Here I'm excluding the ID column. I'm passing the index. Okay, here is my normalization function. And by now you're familiar with this function, I'm assuming. Okay. So if I normalized the data frame, my data set, so this is what it is looking at. I'm saying x underscore train and x underscore test. These are my test and train data. So if I look at this, so this is how it is looking. $21. I'm considering 21 as my k value. Okay, I say knn dot fit. And then I would like to predict. Okay. Now let us evaluate the model. So let us look at the accuracy as well as the test. Okay. So now let us predict the train data. Okay. You're getting 30%. So what you do is you either add the data to your existing data set, or you do hyperparameter tuning. Okay. So that is one scenario. That the accuracy is very low. You can just add the data, simulated data. Okay. So we are running the KNN algorithm for close to 3 to 50 nearest neighbors, and all of these are odd numbers. Okay, now let us run this. Multiple lines of code. I'm running a for loop. This is what it is giving. That is the train accuracy. And then we look at test accuracy. Okay. So this is how you deal with k nearest neighbor, and it is a supervised learning technique. Right? All right, friends, we will stop our discussion here for the day, and we will continue in our next session, and we will meet on Monday. Thank you all, friends, for joining. You all have a good day.